Now that we've hopefully improved the calibration of our speedo, it is time to look at our compasses. So if you've declared multiple compasses, they would appear up here, compass 1 and compass 2. And we have two graphs in this feature. So probably the first thing I like to do is to draw them with the wind up. So then it's easier to find what is upwind on starboard, upwind on port tack, and the downwind down there. Now, on this first graph, every point corresponds to a straight line phase which we created earlier. And I think what would be the most interesting is to zoom in, for instance, on this starboard tack. So let's do a little bit of explaining here. As mentioned previously, each point corresponds to a boat speed and heading. So our heading here will be around 154, 155. And then the boat speed corresponds to this vector here. And then the tail will correspond to speed over ground and course over ground. So we do expect, so that means that when my boat was pointing that way, going in that direction, in fact, over the ground, it was pointing that way, going in that direction. Now, I think what will be the most interesting are these average trend lines. The solid one will take the average of all those points for boat speed and heading. Then the dashed one is the average of SOG and COG. So this is how we're going to play with all this. We then have a little blue line here, which represents the tidal current, which we specified in the previous video. And then this gray line is the leeway. Now, the leeway, at this stage, we specified just use the leeway from the log. And what would we expect? We would expect that this, taking the boat speed heading, adding tidal current, adding leeway, that would match exactly our speed over ground and course over ground. Here it's pretty close, so there's a little bit of delta maybe in speed, but it's really pretty close. If it wasn't, there would be two reasons for that. Well, three reasons possibly. Maybe you would need to go back and respecify a different current, ideally from your observations or some kind of measurements or a grid file. And then we can also start playing with maybe a different leeway setting. So let's say if the leeway factor was only 10, we see that that means we'd be drifting a little bit less and we're not quite reaching this SOG and COG. So let's go back to 12, is probably a good number here. So this is how we could play about trying to correct and find an improved leeway coefficient. It turns out in our example, this leeway coefficient looks actually pretty solid. Now, if you still find a delta between those two, then possibly what is left is that there is an error in your compass readings, and you can now go into your correction tables for the compass. So let's look at post-calibrating that. Here we are around the 150 line, so let's simulate that there's maybe a 1 degree deviation we'd like to enter in this table. It made things worse for us. Once again, I think this data is actually quite well calibrated already. But this is how you would play with those settings and try to get the vector of the boat speed heading plus the current plus the leeway to match the SOG-COG best possible. You would have to do that on all points of sailing and make sure that if you improve one side, you're not making the other one worse. Now, let's just have a quick look at the graph on the right. What we're plotting here is the delta between the heading and the COG corrected for currents. So you see when it's in the white part, that means the heading is reading a little bit more than the COG. And if it gets into the blue, it is reading a little bit less. So it's just another way to view this data, and possibly you could use this trend line to find what correction you should enter in this calibration table.